Hi everyone, my name is Kristen Yu and I am a PhD candidate at the University of Alberta. My advisors are Matthew Guzdial and Nathan Sturtevant. One of the major tenets of computer science or science in general, is reproducibility. So you have an experiment and you get some results and then you publish those results. But usually the people who publish the results don't actually verify that you can get those results again. In the realm of computer science, there are a couple of things that can help you reproduce results. Some of those artifacts might be algorithm description, the research test beds, or in our case, a data set. There are some existing data sets that are used in gameplay or in video game research. So one of those is the Power Wash Simulator, which is a simulating game. There's also a lot of Mario data sets, which is a platformer game. However, we're focused on FarmQuest, which is a cozy game. So we want to expand the amount of, or expand the genres available data sets. So FarmQuest is a research testbed that I've created. It's a farming game and it has a couple different gameplay modes. So this is the main gameplay loop. You can harvest mushrooms or berries. You can plant seeds, which then grow into crops. You can place furniture and decorate your house. And lastly, you can cook food out of the ingredients that you've collected. There's also, the research testbed is also designed to evaluate AI director research. So the AI director is implemented in the quest system. So this is a picture of what the player sees when they interact with the quest system. This is on the accept quest tabs. And as you can see, there's 3 different quests for the player to choose from. When the player actually wants to complete a quest, they just click on the quest that they want to complete. The job of the AI director in the system is to choose which quest to show to the player. There are 3 different AI directors in FarmQuest. The first one is a random AI director, which will just randomly select quests to show to the player. The second one is passage. And so passage uses the previous actions that were taken by the player in order to predict which quest should be presented next. The last one is my personal AI director, which uses the previous quests that were selected and uses a bandit algorithm in order to predict which quest should be shown to the player. We ran a human subject study to collect this data. So first we asked everybody some demographic questions. Then we gave everybody a tutorial to learn how to play the game. Then we had them play FarmQuest with a randomly assigned AI director. They completed a short survey. They played FarmQuest again with a different randomly assigned AI director. They completed a short survey and lastly completed a comparison survey about their 2 experiences. You'll note here that the players did not actually play through all 3 different AI directors. They only played through 2 out of the 3. For the demographics of this data, we had 39 players. They're mostly males. They're mostly on the young side. They mostly play games. And they play a variety of different games. And this is just what we were able to sample from. The dataset itself is a collection of a couple of different things. It has a bunch of telemetry events for when the player actually played the game. So this is some of the events. This is not all of the events. It also includes the survey data. So the short survey that was given to the players after they played each FarmQuest is shown here on the right. And then the comparison survey is shown here on the left. It's mostly Likert questions, so most of the data is values, but there are 2 free text questions that were provided in the comparison survey. So this is what I'm offering to you guys. You can use this data set to check my results. And there are also some other future works that you could potentially use this data set for. One potential use is churn prediction. So we ran a really simple logistical regression to check the number of in-game days that the players played. As you can see here, the samples 2 and 3 had a pretty accurate result of using just a simple logistic regression. But for our last sample, it wasn't exactly the most accurate. This is a really simple churn prediction technique. So there are other churn prediction techniques that could be more accurate. I am just not a churn prediction researcher. There's also potentially could be used in player modeling. There's a variety of different gameplay inside of FarmQuest. So one of the things we did was we used data-driven player modeling to try to see if we could identify players that were liking certain types of gameplay. It wasn't quite successful. As you can see here, there are 3 distinct clusters in session 1 passage. but there are 4 distinct clusters in session 1 CMAP. So there wasn't any direct player types that we could identify out of this particular data set using the techniques that we used, which were, again, very simple, but there could be more complex or even non-driven player modeling that could be used to identify player types within this data set. The last one is next action prediction. So most of the time, we used n-gram, really simple n-grams to just predict the next action. We use trigrams, bigrams, and unigrams. Most of the time, they predict the same action, but sometimes you can get other actions predicted, and that's kind of cool. But if you have any questions about this data set or about the experiment in general, you can come visit me at my poster tomorrow.